Hi everyone, this is Mrs. GA, and today we're going to do some problem solving with trigonometry. So first we are going to learn about a new way that you can find the area of a triangle that uses trigonometry. So the only way that we've learned so far is just that simple 1/2 base times height. However, the issue there is that you need to have an altitude as the height. And sometimes that's not always an easy thing to find. So this formula, it's really just the same formula, but just adjusted for different side lengths, can help you find the area given 3 pieces of information. So what you need are two sides such as A and B, and then you need the included angle. So remember, this is what's called the included angle because it's the angle formed from the two sides that we're using. So if you have two sides and the included angle, you can use this formula. So the formula is just 1/2 times one side length times the other times the sine of the included angle. So these are just adjusted for different side lengths. So here you have B and C with sine A would also work, and then 1/2 A and C with sine B. So again, all you need are two side lengths and the included angle, and you can use this formula to find the area of a triangle. So let's look at this first example. Here, this would be very difficult to do using 1/2 base times height because we need to have a vertical height and we don't have an altitude given. So this, since we have two side lengths and the included angle, we can use the formula 1/2 times 8 times 6 times the sine of 87 degrees. And then this is just something that you would plug into your calculator to get a decimal approximation. So 1/2 times 8 times 6 times sine of 87 degrees gives us approximately 23.97, and we'll say centimeters squared. So I rounded to the nearest hundredth here. And make sure you do include your units, which is centimeters, and since it's area, it needs to be centimeters squared. Okay, let's try one more of these together. So again, you'll see that we have two side lengths and the included angle. So we can find the area by doing 1/2 times 6 times 5 times the sine of 140 degrees. And again, this you can plug into your calculator to get the decimal approximation of 9.64. And again, it will be inches squared. Anything involving area, your unit needs to be squared. So that's one useful application of trigonometry. It can help us solve some problems that would be much harder to do with our old area formula. So now we're going to move on to some right triangle word problems. So for these, we're going to be using our SOHCAHTOA ratios, and really the trickiest thing here is drawing the picture. So we need to make sure we can interpret the words into some sort of picture that allows us to solve. So this says, a boy who is flying a kite lets out 300 feet of string, which makes an angle of 60 degrees. Sorry, this was supposed to say degrees, with the ground. Assuming that the string is stretched taut, which means there's no lag, it's just a perfectly straight line, find to the nearest foot how high the kite is above the ground. So let's draw a picture. Let's say here's the boy, and he has a kite that he lets out, and the string is 300 feet. That's how much he lets out. So here's our kite. Okay. It says that the string makes a 60-degree angle with the ground. So that means that this angle, which is actually called the angle of elevation, is 60 degrees. So here they want us to find how high the kite is above the ground. So of course, since we've been doing trigonometry, we're always going to turn this into a right triangle. And if I want to know the height of something, I do need the perpendicular distance to the ground. So I do need this to be a 90-degree angle with the ground. So this is what we are trying to find. So again, let's look at what we're using this angle. This would be considered the opposite side, And this is our hypotenuse. So you ask yourself, which trig ratio uses opposite and hypotenuse? And that would be sine. So we say the sine of 60 degrees is x over 300. So multiply both sides by 300. So 300 times the sine of 60 degrees. So x equals, and this we can get a decimal approximation for. So you'd plug that into your calculator. And you get approximately 259.81 feet. That's how high above the ground your kite is. So again, as long as you can set up the picture, the rest should just be using SOHCAHTOA to solve for a missing side, or maybe even a missing angle. All right, let's try a few more together. So let's look at example B. A 40-foot flagpole has a rope tied from the top to the ground. So we can sketch a picture of that. Here's our flagpole, which is 40 feet. And it has a rope tied from the top to the ground. That's our rope. And it says the rope makes a 25-degree angle with the ground. So here's our ground, and here's the angle between the rope and the ground. So that angle would be 25 degrees. How long is the rope? So they want us to find this. And we are just going to assume that the flagpole is vertical because most flagpoles should be vertical. So here again, look at what we have. We have the opposite side and the hypotenuse. So we're going to be using a sine ratio. So sine of 25 degrees is 40 over x. So multiply by x. And then we're going to divide both sides by the sine of 25 degrees. So here we can get a decimal approximation again from our calculator. So 40 divided by sine of 25. That gives us approximately 94.65. And then make sure we check our units, which is in feet. And there you go. Okay, so this next problem has a really important phrase that you'll see a lot with these types of problems. It's angle of elevation. Another phrase that you might see a lot is called the angle of depression. So the really important thing to know whenever you see the words angle of elevation or angle of depression, the one important fact is that it must be created by connecting your line to a horizontal line. So notice my angle of elevation, one side of my angle is always going to be a horizontal line. Same for my angle of depression. One side of my angle must be a horizontal line. So sometimes, you don't have a horizontal line naturally, like maybe you're up in the air. You can always draw in an imaginary horizontal line so you can draw this angle of depression or elevation, but it must be touching a horizontal line. That's the big rule. So this one says, find the angle of elevation if you are standing 40 feet away from the building that is 850 feet tall. Okay, so here's our building. And our building, again, is 850 feet. And you are standing 400 feet away from the building. And here what they ask for, again, is the angle of elevation. So we're going to draw a line from where you're standing to the top of the building. And since this is touching our horizontal, this would be our angle of elevation. So we're actually going to be finding the angle this time. So we look at it and we say, okay, I'm using this angle, which means this would be the opposite side and this is the adjacent side. So I know that I need to use tangent because tangent is opposite over adjacent. So we say tangent of theta equals 850 divided by 400. Remember, when we're finding the angle, we swap these two values and we will now use arctangent of 850 over 400 equals theta. So remember, we read this arctangent of, and then the value, and then that will equal our angle. So we're going to plug this into your calculator, and it will tell us that theta is approximately 64.80 degrees. So that would be our angle of elevation. All right, let's look at this next example. So here, a ladder leaning against a house makes an angle of 30 degrees with the ground. So let's say here's the house, here's the ladder, and it says it makes a 30-degree angle with the ground. The foot of the ladder, which is the bottom of the ladder, is 7 feet from the foot of the house. So they're telling us that this distance is 7 feet. And they want to know how long is the ladder. So they want this length. And again, we're going to assume that the house is perfectly vertical. So again, look at what we have. Here we actually have a special right triangle. This is a 30, 60, 90. So maybe just for practice, we can solve it using a 30, 60, 90. Again, you could also use SOHCAHTOA, but this is just for practice. So again, one way you can solve these is by creating similar triangles. So I'm going to draw my own 30, 60, 90, and I'm going to mark it up. So it's always 1, 2, square root of 3. Remember, 1 is always opposite 30, and 2 is always our hypotenuse. And now we can match up the corresponding parts. So x goes with 2. X over 2 equals 7 over root 3. And then if you multiply both sides by 2, you get x equals 14 root 3, which we could rationalize, giving us 14 root 3 over 3 feet. Now, the problem here is this is a real life example, so if you were to tell someone this measurement in real life, they would have no idea what this is. So usually for word problems, it's best to get a decimal approximation. So we would actually plug this into our calculator to get a decimal approximation, and we get approximately 8.08 feet. So this would make a lot more sense to just a normal person. If they asked you how long is your ladder, you'd say about 8 feet. Okay, let's look at this last example together. So this says from the top of a tower, the angle of depression, so we need to be very careful with this, to a stake on the ground is 60 degrees. So here's our tower, and it says from the top of the tower, the angle of depression to a stake on the ground. So here's something, that stake on the ground, here's our ground. Now, here's the thing. A lot of people automatically look right here and they say, okay, this must be 60 degrees. But remember, our rule for an angle of depression is it must be touching a horizontal line. This angle is touching a vertical line. So we actually need to draw in our own horizontal line here, and they are talking about this angle. This angle is 60 degrees, which means that in here, this angle is actually 30 degrees. So be really careful. Angles of depression must be touching a horizontal line. It says the top of the tower is 80 feet above the ground. So this length is 80 feet. And they would like us to find how far the stake is from the foot of the tower. So they would like us to find this distance. So we can use this angle. Again, we have another 30, 60, 90. Let's solve this one this time using a trig ratio. So here, we know this would be the opposite side. This is the adjacent side. And that means that we're going to be using tangent. So the tangent of 30 degrees is opposite over adjacent. X equals 80 times the tangent of 30 degrees. So here we'll want a decimal approximation. And we get approximately 46.19 feet. And there you have it. All right, so that's all for today's video. Thank you so much for watching.